Hi, everyone, and welcome to the overview of Chapter 6. Now, I want to alert everybody that Chapters 6, 7, and 8, the last three chapters before our midterm, the author throws lots and lots of names at you. And so what I'd like you to do with these three chapters is I'd like you to read them, I'd like you to take notes on them. However, I'm going to ask that you focus specifically on the scientists that I highlight here in the overview. I will not ask any questions in the midterm of any scientists mentioned other than the ones that I want you to focus on. So in the Chapter 6 overview, the author started in Chapter 5 talking a little bit about Edmond Halley. I'd like you to focus on Edmond Halley, Carl Linnaeus, sometimes you'll see it spelled Carol Linnaeus, but Carl Linnaeus, Georges Cuvier, and Jean-Baptiste Lamarck. The reason we're focusing on these is because these scientists not only have important contributions, but they also tie into strands that are talked about and discussed later in the book. So let's go to Edmond Halley first. Edmond Halley, this is a picture much later of Edmond Halley on the right and Isaac Newton on the left. They were contemporaries. Halley was a little bit younger than Newton. And Halley was just an extraordinary scientist and had lots and lots of accomplishments. One of the first is his discovery of how far the sun was from the Earth. And the way he did that was through studying the parallax of the sun as Venus passed in front of it. There's a diagram here from his study on this, Dr. Halley's dissertation on the parallax of the sun by the transit of Venus, June 6, 1761. This started to establish Halley as one of the premier scientists of his time. He also studied magnetism and was one of the first to draw maps that had lines of magnetic variation on them. This is such a map here. He was eclectic. He studied lots of different things. He invented a diving bell so that undersea work and salvage could take place. Here are a couple diagrams from that. Of course, we all know him still to this day by the prediction of Halley's Comet, that the period of Halley's Comet is about 75 years. And here's a shot of Earth's orbit, just a diagram, the sun and the comet orbit. Let's take a look. Here is a chart of Halley's comet predictions and when it would occur. And the fact that his predictions came true just, vaulted him to really high standard among scientists. Okay, the next scientist that we're going to look at is Carl Linnaeus. And Linnaeus was the first to organize nature. His famous book is called Systema Naturae. And in it, we come across the organization that many of us are familiar with. Kingdom, this is the animal kingdom, the animals that have chordates or backbones, mammals, carnivores, and then finally down to genus and species, the Canis lupus, the wolf species. So Carl Linnaeus was the first to organize all nature, not just animals, all nature into this system. And it started, one of the reasons why that was so important was it started to make a system that was easier for scientists, biologists, naturalists to see patterns in nature and to see how different organisms were related to one another. Here's one of his sketches from his book. The next scientist that I'd like you to look at is Georges Cuvier. Cuvier, I'm going to read from this poster that I have here. Cuvier recognized that different geologic strata, there in the upper right, contain unique groups of flora and fauna, plants and animals. The deep strata contain organisms that are the most dissimilar to the present day. So this type of evidence is really, really important. The other thing was a lot of people believe that there was no such thing as extinction before Cuvier. And as you look on the left there, it says, after this work appeared, it was no longer possible to deny the reality of extinction. So the work that Cuvier did on animals and extinction and rock layer laid the groundwork for Charles Darwin, as we'll see a few chapters. Actually, we'll see in the chapter right after the midterm. This is a shot from his book where he was excavating fossils, and he has the different caverns and the work that was done at different layers. Why has not anyone seen that fossils alone gave birth to a theory about the formation of the Earth, that without them, no one would have ever dreamed that there were successive epochs in the formation of the globe? That's a quote by Cuvier. Cuvier was quite a good writer as well as a scientist, and had lots of famous quotes about it. The last scientist that I'd like you to focus on in this chapter is Jean-Baptiste Lamarck. And Lamarck was, as this says, an early evolutionist. At first, he was opposed to Darwin's theory of evolution, and we'll talk about that a little bit later. Lamarckism, his theory of evolution, he said that, for example, let's say you have two parents that are bodybuilders and they strengthen their body really, really well. Then they decide to have a child. That child is just going to come out with muscles all over its place. Really acquired, inheriting characteristics that were acquired by use and disuse of the previous generation. Okay, so focus on Lamarck, on Cuvier, on Linnaeus, and Edmond Halley in this chapter. Remember, there'll only be questions on the midterm of these four, so you want to know what their contributions were. And again, I'll only ask very general questions. Please note that we've lined up two midterm time slots for you to choose. They will either be, you will be coming for the midterm either on Tuesday, October 20th from 4 to 5:30, or Thursday, October 22nd from 1 to 2:30. Please keep in mind, I'd like you to jot this down now, put it on your planner, and if you have any problems, to email me directly, and we will set up a time. Hope you guys are enjoying the text, and sorry for